Okay, now I'm going to run through this. I'm going to bypass the floor. I'm going to look up at the ceiling. And on the ceiling, I see, oh gee, how many again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14 ceiling tiles across and 16 that way. So the ceiling, I before E except after C, right? The ceiling is covered by 28 times 32. Actually, it's 14 times 16. Sorry. 14 times 16 tiles. Or what? 14 times 14 is 196. Okay? And another 2 times 14 is 28, so that's 224 tiles. Okay? Each tile is a 2-foot square, i.e. 2 by 2, well, 2 feet by 2 feet. Okay. So the tiles on the floor are 1-foot tiles. You should pause for a minute and use this to figure out how many tiles there would be covering the entire floor. Well, hopefully you've paused and you've seen that it would take four, F-O-U-R, 1-foot tiles to cover a 2-foot tile. I draw a picture of that. Here's a 2-foot tile, and there are your 1-foot tiles. 1 foot, 2 feet. 1 foot, 2 feet. It takes 4 of these to cover this one. And of course, you can multiply the 2 feet by the 2 feet to find that they're 4 square feet. So it takes 4 1-foot squares. Okay, it takes 4 of these tiles to cover a 2-foot tile. So if we're going to cover the ceiling with 1-foot tiles, we'd need how many? Figure this out. Hopefully pause and figured it out. Okay? Well, it would be 4 times 224 equals, what's that? 4 times 200 is 800, 4 times 25 is 100, so 4 times 225 would be 900. 4 times 224, being 1 less than 225, would be 4 less than 900, or 896. One-foot tiles. Now that's higher than the estimates people made on the floor, but the floor is kind of a mess. It's hard to count. It's hard to see how many tiles there are under that side of the floor because the cabinets cover the entire length of the room on that side and most of the length on this other side. Okay, well, so there are 896 1-foot tiles it would take to cover the ceiling. Okay, to cover the floor, well, the ceiling has the same area as the floor, assuming that they managed to build this room as a rectangular solid, okay, a rectangular, everything at right angles with one another. Don't want to get it. It's a rectangular parallelepiped. You don't want to know what that means. Okay. Or maybe you do want to know. That's what it means. Okay. So there are 896 1-foot tiles. Okay? Now, the room, as best we can figure it, is 104 inches tall. Okay, so let's see. I can say that it would take 144 times 896 1-inch tiles to cover either the floor or the ceiling, which have the same dimension. Okay? And what is that? Let's see, 144 times 1,000 would be 144,000. 144 times 100 is about 1,440. 144,000 minus actually 14,400, not 1,440. It's going to give you about 130,000. That's one, not on 1-inch tiles, okay. So take 130,000 of them, okay, to fill the room. It would take how many? Okay, well, that'd be 130,000 times the 104-inch height. Okay, that's the number of tiles to cover the floor, and that's how many tiles I'm going to write that as the height of the tile stack. Okay, you can imagine 130,000 tiles covering this floor, and then on each of them you have a stack of 144 blocks. Now I said tile stack. That'd be a stack of blocks. For each for each 1-inch tile. And that's about 13 million blocks. So you just imagine a good, average size, typical size classroom, maybe a little bigger, filled with 1-inch blocks. It would take 13 million of them. Now, if we had these dice, okay, at 2 per 1¼ inch length, I'm going to figure it out this way. The volume of a single die, well, actually, let's digress for a minute. Let's go back. That's going to get me into fractions that I don't want to lay on you. I'm going to do that a different way. We're going to start that in a separate video.